Okay, ready on the next capacitor here. This one is buried under here, and I think you can see, you can read 0.022 on it. Let's see, one connection goes to here, and the other one is bent back and goes to here, and those two connection points are fairly in the clear. 0.022. Now, let's see, can I get two capacitors into that spot? 0.022. I think I probably could get two in there in parallel. So to do the 0.02, 0.022, I put two of these 0.01s in parallel. Maybe these guys here. Why would I want to use those? They, or 2.01s. I think I want to keep my 0.01s. I got, you know what I got? I got lots of 0.015s. So if I did a 0.01 and a 0.015 in parallel, I get 0.025 instead of 0.022. That's pretty darn close. 0.022. And pretty small. I think I can pull that off. Let's just see if I can do something tricky here. There we go. Okay, so there's the two of them. I've already twisted them together. Just dab a little solder on them here. I've turned my soldering iron down a bit. No, hold still. Now, what's lighting this thing? Wow. My camera is very sensitive to light. So this is all washed out, but the amount of light that's in here, you'd be surprised how dark it actually is. How dark it is to your eyes. Guess it's all relative, isn't it? Okay, so there's our parallel capacitor package, if you like. Hey, looks like the space shuttle on the back of a airplane. Well, I guess you have to stretch your imagination for that. Now this guy is going to go in. Let's see if I can get the camera back where it needs to be here. Okay, there he is down there, buried. Let's see if we can get him out. There's one end. Okay, I think I can get down between these two resistors here and nip it. I have another pair of more delicate cutters that you can fit into a tighter spot. But somebody I'm married to 20 years ago tried cutting coat hanger wire with them, and they don't work so good now. They have big dents in the cutting blade surfaces. Don't tell her I said that. So out comes the 0.022, in goes the combo 0.01, 0.015. Just double checking on everything I'm doing here. Yeah, now we'll do the easy lead first again. And I got the whole connecting terminal is available for this one. Oop. In you go, in you go. That's pretty good. Whoops, not so good now. It just fell off. Let's get it back on. Okay. That's good for soldering. Big terminal here, take a lot of heat. There it goes. Okay, now let's make absolutely sure I'm about to put this on the right terminal. I think I am. Move this resistor back up. Yeah, another thing too is, of course, you're watching this without the benefit of stereo view, except when I shake the camera a little bit, that might give you some idea of the depth, and I'm doing everything I can to keep two eyeballs on the point I'm looking at to maintain stereo depth perception, or this becomes really difficult to do. I guess if we want to go further with the surgical analogy here, there's one heck of a difference between, well, of course there's huge differences between surgery and this. The big one is the, you know, you don't turn off and unplug the patient while you work on him. You got to keep him playing the whole time. A human being. So imagine if doing this kind of work required that the radio be playing non-stop. I could only tolerate momentary interruptions of operation. I'd have to have two more technicians in here with me, concentrating on compensating for what I'm doing here. And wouldn't I feel time pressure? Yeah, so certainly don't mean to compare this to medical surgery, but it is fun because what it highlights is, you know, without me actually trying a little surgery on somebody, I can get a much better appreciation for what surgeons face. I think it would be downright terrifying, considering how many times I've started something here, expected it to go, you know, procedurally, I guess you could say, and then right away I end up having to solve a myriad of silly little problems with the physical position of things, and that must be a bloody nightmare for a surgeon. Ah, bloody nightmare, that's pretty good. As opposed to a shocking nightmare like this. Okay. I should watch back the video and see what it is I'm talking about, because I'm half concentrating on what I'm saying. So I hope I'm not saying anything too stupid here. Here we go. Oh yeah, that's in there good. That's another one done. Who's next? The next hardest one is right a little bit hard to get this angled up just right. There he is. Kind of on the right side of your screen there. But I'm going to have to change the camera angle because I can't work with it like that. So I'm going to swing it around. Not quite there. There he is. that guy there. And not nearly as difficult as the last couple have been. Okay, you, come out of there. This one is a, guess what? It's a 2200 picofarad, which is the same thing. 2200 is the same thing. 0.022. Point 0.022. 0.0. You know what? If I put a couple of 0.05s in series, 0.05s in series, can I fit that in there? 0.05s in series. I think I can, so I'm going to try that. 2 0.05s in series, that would be 0.025, isn't that right? I think so. I'm just making up the serial combination here. And it's going to be a tight fit in there, no doubt about it, because 2 of these in series are pretty long. I'm doing this off camera because it just takes a fraction of a second to do. Still got that wire to hunt out in the radio. Don't want to forget about that. Okay, now it's a bit large. 2 in series. We'll do the upper one again because it's very easy. Okay, that can actually be soldered like that. Pretty good. Boy, where would we be without solder? And now the other end, get rid of the long lead on it here. It's got to go down and catch that. Don't cut it too short here. You can always cut it again. Down it goes. that. Let's cut a little more off. Now, I'll try and make this connection here. Definitely easier to work on than the others. Oops. That's pretty much solderable like that, though. Yep. The owner of this radio requested that it be fixed up real good. That was his comment. So I'm not so reticent to replace tired old capacitors, even if they're not exhibiting a problem at this point in their life, or a serious problem. Because the owner wants the radio fixed up good, and this is part of doing a good job. Getting rid of these tired old problematic capacitors. I be honest with you, I've opened up radios and there's been 30 of these in it. And when the radio went back, it still had 30 of them in it. Yeah, you can see how long it takes to do each one. It's not a 5-minute deal. You know, maybe in an All-American 5 you can pull these off pretty quick. Okay. Okay, now I think I've made a mistake here. Yeah, I think I've gone and put this on the wrong terminal. It needs to be down here. That would be over here where my finger is. Yeah, I've gone and put that in the wrong spot. It's just so easy to make these kinds of mistakes, which is sometimes, you know, the less done the better. So, yeah, what happened here is I looked for the cut end of the original lead wire and spotted one up here, and of course that's from a previous operation, putting in this capacitor here, and I missed. Look, here's the lead wire down here, sticking out here. That's how easy it is to make a mistake, and then you can spend a long time trying to find what it is you did that was wrong. I almost did one here. So that's the lesson there for everybody, including me. I'm going to do this kind of stuff. You probably are going to make mistakes. And that's why I've watched back a few videos, just to see what the heck I did. Because oddly enough, you know, when I'm producing these videos, I have no time to watch them. I can't sit and watch all my videos and see how they come out. I haven't got the time. That's why the comments are so important to me. And okay, we can solder that in place. That, I would call that a real close call. A real close call. What's going on here? Okay, we got them in there. Got 1, 2, 3, 4 more in this circuit to do. Let's get ready for the next one.